Hello everyone, I'm Laurent Dubu from RTE and OMC. I will briefly introduce the Copernicus Climate Change Service for the energy sector, and more specifically the energy conversion models and the associated dataset. C3S Energy has produced climate and energy datasets which aim at assessing the effects climate variability and climate change have or will have on electricity demand and generation from wind, solar PV and hydropower. It will be beneficial in anticipating important climate-driven changes in the energy sector through either long-term planning or medium-term operational activities. The data covers a wide range of time periods, historical, seasonal forecasting, and multi-year projections. The energy data is provided at different geographical levels. EU countries are not zero for all variables, but also at grid point level with 25 km resolution and NUTS 2 regions for wind and solar power. The conversion models were developed to provide a multivariable, multi-timescale view of the climate and energy systems for the whole Europe, and this is why we privileged flexibility of the models against high level of accuracy. Different kinds of models have been used depending on the energy variable under consideration. In all cases, observational data is necessary to calibrate the statistical models and to validate all of them. ENTSO-E transparency platform is a very good source of information. However, it provides data only from 2015, and there are some issues in some datasets. We think it's critical to improve observational energy datasets. This will first save time and money, and will also allow to develop better and more accurate models. In a few words, data is king. We show here only two validation plots for demand in Austria on the left panel and solar PV power on the right panel. The scatter plot for demand is representative of what we get for most countries, where good enough data is available to train the models. Overall, we get a good fit between modeled and observed demand, with mean absolute percentage errors smaller than 3% in most countries, and even close to 1% for the countries with the best observational datasets. For solar power, the physical model allows to reproduce with a fair accuracy the capacity factor in most countries, except those with significant orography, for instance Austria or Switzerland. A paper presenting a comprehensive description of the models as well as their performance estimation is in preparation. A key message is that the quality of the models and their validation is hindered by the uncertainty in the reference data. However, the simulated data are plausible and available for many variables and most EU countries. Potential improvements have been identified and will be implemented in the near future. The C3S Energy dataset is currently being ingested into the C3S Climate Data Store. If you want to know more, please contact us or visit the C3S Energy website. Thank you for your attention.